Hi everyone, my name is Ivan and I'm the founder and developer of the Bastionne blockchain. What is the Bastionne blockchain and how does it compare to a regular blockchain? Well, current blockchain technology with its external device validators does have its use cases. However, many industries and services are currently underserviced by blockchain technology due to ergonomic and privacy concerns. So industries like the banking sector that need private and secure credential sharing solutions, the regular business sector that needs private and secure document transfer solutions, and app companies that need affordable in-app purchase solutions, all of those industries are mismatched by current blockchain technology. Hence, we created the Bastionne blockchain. So, what is the Bastionne blockchain? It is a peer-to-peer blockchain that uses artificial intelligence for real-time private and secure applications. What can you do with the Bastionne blockchain? Eliminate spoofing and phishing, send secure messages or OTPs, send private content containing sensitive information, and more. Things like password recovery handlers, new account registration verification codes, all of those things can be securely and privately executed with the Bastionne blockchain, and it is affordable as it reduces data costs. What makes Bastionne a better blockchain? So before I go into that, I'm going to provide you a quick overview of what a blockchain is so that I can highlight the nuances thereof and thereby better demonstrate the benefits of the Bastionne blockchain. So, what is a blockchain? In reality, it is a simple concept made needlessly obtuse by programmers and crypto enthusiasts. Jokes aside, it is simply a method to store and exchange data that leaves an auditable trail to verify data entries. It is very similar to the double entry ledger system invented by the Italians during the Renaissance. Okay, let's do a quick example. We have 4 schoolboys, Adam, Sam, John, and Dan, who have various heights. We want to put the schoolboys' heights on a blockchain so that it can't be altered on a later date. Okay, so we grab a piece of paper and first we list the tallest boy, whom is Adam at 1.85 meters tall. And in orange we add a tag to his name and we put in Genesis. Okay, this is the Genesis block of our blockchain. Secondly, we put in Sam, who is 1.81 meters tall, and in his tag in orange we put Adam, whom was the previous block of the blockchain. Okay, so you can see Adam and his corresponding height. Next up, we put John, who is the third tallest boy, at 1.79 meters. And in orange we put his tag there, and we put Sam, which was the previous entry in there, at 1.81 meters tall. Okay. Then lastly, we list Dan, whom is the shortest boy, and in his block, orange block, we put in John, whom was the previous block of the blockchain. So you can see each entry is linked together or chained together by the previous block, hence blockchain. Now we make a copy of this piece of paper and we give it to external validators, or we keep it safe in an external location. So we're going to make 3 copies, okay? So we have our original blockchain document. Let's say someone wants to hack it. For example, Sam goes and he changes his height from 1.81 meters to 1.84 meters, as you can see marked in red at the second entry. However, it is immediately detectable that this blockchain has been breached, as the next entry the third one, has its corresponding block listed as SAM being 1.81 meters. This blockchain is no longer correctly linked to the previous entry. Resultingly, it will be declared invalid. This was a very basic blockchain attack, and it is immediately detectable on the blockchain. However, let's say someone wants to do a more sophisticated attack. For example, John goes and he changes his height to 1.8 meters. However, he also manages to change the next entry's corresponding block to him being 1.8 meters. This blockchain will be declared valid as it is correctly linked to the previous entry, even though it was hacked. Okay? So, how do we know that this blockchain was hacked for security purposes? We simply compare it to one of the copies of the blockchain that we made earlier and gave to a validator. Okay, so it's simply going to go through the list one by one, and eventually it will pick up that the third and fourth entries no longer match the copied document. Hence, this altered blockchain will now be declared invalid. This entire process is done by your external validators or miners. So, what makes a blockchain better than a double ledger entry system? Computers prefer blockchain because it can more easily and quickly read and compare a list of information compared to a debit and credit system spread across different accounts. If you think about it, a debit and credit system is essentially a multi-dimensional in and out system compared to a list of data which a computer can easily and readily process. What are the flaws of current blockchain technology? Firstly, it is not private due to external validators who confirm the blockchain. Therefore, blockchain is not usable for applications where privacy is of concern. As you can imagine, it is not a very good idea to put private passwords or account details on a public blockchain. Secondly, it has slow data entry rates, and irrational rejected entries are fairly common, because you have to send a copy of the new blockchain to each validator or node before they can validate a new entry. For example, let's say I want to send a secure message via a blockchain. First, I need to upload that message to the blockchain. Then, external validators need to validate the new entry on the blockchain, and it can range from a few hundred to a few thousand external devices that need to validate that entry. And then only can the intended recipient access and utilize the message that I sent him. As you can imagine, this entire process can take quite a bit of time. Lastly, it is expensive. External validators incur great data and electrical costs when verifying the entries on a blockchain. Consequently, the usage cost of the overall blockchain is too expensive for most applications. It is not really feasible to put a bit of data on a blockchain, and it costs $60 for something that would usually cost 20 cents, like a SMS or push notification. So, what is the solution to the aforementioned? Better blockchain, the Bastionne blockchain. Bastionne uses artificial intelligence that enables the intended receiving device to privately and securely validate and confirm the blockchain by itself. No need for any external validators or external validation devices, thereby affording a real-time blockchain security solution with control and privacy for applications that need it. What are some of the main uses for the Bastionne blockchain? Spoofing and phishing-free communication, secure peer-to-peer or mass messages, private content and sensitive information sharing, login or confirmation credential and OTP sharing, and more. That concludes the video. The Bastionne blockchain will revolutionize data management, privacy, and security for many industries. If you want to get your business ahead of the game, please have a look at our website. Link is in the description. Thank you for watching.